Distances horizontally, we're counting distances vertically just by walking. For example, when I'd walk to the back row, we knew it was 12 steps. What's the halfway point of 12? 6. And what's the halfway point of 10? What's the halfway point of 20? What's the halfway point of 5? 2.5, 2.5, okay? The idea here is you're still just walking halfway. Now, it works out nicely when you're going horizontally or working vertically. What happens, though, if I got to figure out where it is there? So this is when you have to start thinking about things in terms of what is called 2 dimensions. When I'm just walking in a straight line, it's a singular dimension. It's like a number line. You're just counting on number line. When I do this via 2 dimensions, like ordered pairs, if you will, let's say I've got an ordered pair at 3 and -4. Obviously, this is not to scale. Actually, we'll do this. We'll do -3, +4. And then on the other side, let's say we've got 5 and -6. When I do that, let me get that again. Let me do that. When I do this, those are ordered pairs. Ordered pairs has an x coordinate and a y coordinate. You guys agree? Ordered triples would have an x, y, and z that would be in 3 dimensions, outward and outward like this. So when we get to two-dimensional land, instead of just walking in a number line from what's halfway of 0 and 12, I'm walking the number line now as what's the halfway point of -3 and 5? What's the halfway point of 4 and -6? So all you have to do is take an average. What's the average of 0 and 12? I have no money. She has 12 bucks. How much money do we get? What's the average between the two of us? 6. 0 plus 12 is 12. 12 divided by 2 is 6. If I've got 5, you've got 12. How much is that? And what's half of 17? 6.5. Man, hey, what's up?
He's so loud.
So the idea here, guys, the idea here is you're just going to be taking an average twice as opposed to once. Watch. What's -3 plus 5? 2. What's half of 2? 1. So the halfway point between -3 and 5 is 1. What's 4 plus a -6? What's half of -2? So my midpoint is there. All you're doing is you're adding your x coordinates together and cutting it. Add your y coordinates together, cut it in half. Because watch what happens. If I go from -3 to +1, do I go up or down the number line? How many up do you go? I go up 4, right? What's 4 more up from 1? Going from +4 to -1, do you go up or down? How many? 5. I appreciate the because you were thinking. So going from 4 to -1, you go down 5. What's 5 less than -1? -6. Your distances between the values stay the same as you go through that. You're just finding an average. You add the numbers together and cut it in half. Let me show you how you would do that on the calculator. You can. Yes, ma'am. Watch the language. You just gotta stop it. I did it by accident. You did it like 4 times right there. Anyway, so again, before I get into the formula, which you've got already, think of it this way. I want to find the halfway point. Those are my endpoints. I want to find the coordinate of the ordered pair in the middle. Okay. Again, what we're doing here when you've got endpoints, you have your first and second set of ordered pairs. Now, the actual formula for the midpoint is derived by writing out value. I know that the coordinates of my midpoint, let me explain some of the lettering here. Remember we talked about the term nomenclature? Nomenclature is how things are labeled, how you label stuff. I think I brought up the idea of the RPO codes in the glove box of a car, the build codes of what transmission, what size tires, things like that. Those are all coded usually by 3 or 4 letters with a combination of letters and numbers. So when I'm writing these things down, it's like an X. A lot of people say, oh, it's X1, Y1. Well, the 1, notice how it's written lower? That's called a subscript. In math, when you have numbers that are written below the lettering, it's called a subscript. When you have numbers that are written above it, you guys think of that as an exponent, but technically it's also called a superscript. It's raised up. Okay? So when I say X1, Y1, I really should be saying X sub 1, Y sub 1, X sub 2, Y sub 2, because that means it's the sets of ordered pairs. First set, second set. This means the coordinates of the midpoint. The coordinate of the X midpoint, the coordinate of the Y midpoint. Okay, that's where the X and Y values come from. Textbooks use this nomenclature pretty regularly for showing how the formula works. And just like you were saying a second ago, all it really is, you're taking your X values, adding them together, dividing it by 2. And all that is an average. Okay? It's just an average. Midpoint. That gives you the coordinate for midpoint. So here, if you go long form, shouldn't have to keep telling you guys to stop talking. You're just going to lose you out on your own time. In my calculator, all I would do then is use my fraction bar. A lot of times you're going to get fractions. Sometimes you might get decimals. Remember where the fraction bar was on that multi-view? Take your fraction bar, type in -7 plus 0, and put it over 2. This calculator will automatically simplify the fraction for you. It'll leave it in fraction form if need be. If you don't have the multi-view calculator, you have to type in everything in the numerator first, hit enter, and then divide by 2. Otherwise, what it'll do, it'll just give you an answer of -7. Okay? Because the calculator doesn't know when you're stopping your numerator versus the denominator. Okay? So here, your answer would have been for the x part, -7/2. And if I did that again for the y part, that what the numbers were. 4 plus 3, it's going to be 7/2. So 4 plus 3 over, oops, sorry, got the button first. Then it's going to be 7/2 again. And there's your answer. Anyway, so finding midpoints just means you're taking the average of your x values, you're taking the average of y values. Put them together, cut it in half. Okay? Again, this is something you guys have all seen. What's going to be different now in geometry is that we add a different style step to it. It's not difficult because all of you guys, I'm pretty sure, know how to count. I'm asking a lot. I know it's Friday, but I'm hoping we can count. Okay? Let me show you. You'll get over it. So let's say you have, let's say that M, let's say point M is the midpoint of segment AB. It could be anything. I just drew a line. M, you guys done? I've had it with you guys back there. Okay? Everybody keeps talking. Enough. M is a very common setup. They'll give you M as the midpoint of a segment. They'll give you the endpoint of one of them. Let's say -4 and 3. We'll say that the midpoint is at 2 and 0. What are the coordinates of the other endpoint? You can go ahead and set up the algebra to do all that, but algebra sucks. Let's count. If the midpoint is the halfway point, and I know that from 0 to 12, the halfway point is 6, but the 6 is the halfway, I'm starting at 0. How far is 0 to 6? How much more am I away from 6 then? Well, I just add 6 to it. So, yes, ma'am. I just drew it. It doesn't matter. Not the scale. Don't worry. From -4 to +2. Do you go up or down? Up. How many? How many more? All right. What's 6 more than 2? 8. I went up 6 to get there, which means I have to go up 6 to get there. All I'm doing is counting. Okay. To go from 3 to 0, do you go up or down? How many? 3. What's 3 less than 0? There's your endpoint. Now, just like she was asking a second ago, could you do all the algebra of this? Absolutely. I could have said that I know that the x coordinates midpoint is at 2, the one ordered pair is at 4, plus something divided by 2, multiply by 2, I get 4, add 4, I get 8 equals x. I don't want to do all of that. Nor should you want to do all of that. There's no reason to ever do a graph. There's absolutely no reason to, because it's what happens winds up on a happy. You don't know. Why not just count? Because I know you can count, right? Okay. It is much easier just to count, because from 3 to 0, you went down 3. 3 less than 0 is -3. Let me show you another one. To go from, you've got an endpoint at -8 and 4, you've got a midpoint at 4 and 6. What's the coordinate of the missing endpoint? Remember, all we're doing, I'm sorry, -10 and 6, excuse me, I'm sorry. To go from this then, if I look at the x coordinates, -8, -10. Do you go up or down to go from -8 to -10? How many? 2. What's 2 less than -10? -12. There's your x value. 4 to 6. Go up or down? How many? 2. What's 2 more than 6? 8. You should not have to math this. Yes, sir. Give me a number. Give me an ordered pair. Give me an ordered pair. All right, 6 and 5. Give me another ordered pair. Okay? To go from 7 to 8, to go up or down? Up. How many? What's 1 more than 7? To go from 5 to 8, to go up and down? How many? What's 3 more than 8? This is what I talked about yesterday. Remember how I said that there's shortcuts to things? These are shortcuts to things. You shouldn't have to math a lot of times when you get to this. More often than not, with most of the things that we look at, these are things that you guys have all done. Why not take it that step further and show you guys a quicker way of doing it? Okay. It goes to the same thing we're going to talk about next with distance formula. You guys all did distance formula last year. When you guys did distance formula last year, you guys had the formula, the distance between two ordered pairs was the square root of the change in x plus the change in y quantity squared. You vaguely remember something like that? You did it. I know you did it. You had to do it. If in Algebra 1, that was one of the things you had to do. Okay? Now, what I want to show you, you found the change in x's, you found the change in y's. That's what all this stands for. Okay. Now, so let me show you where the distance formula actually comes from. And it leads into another very easy shortcut. Now, don't draw the graph. You don't need to worry about the graph here. I'm just showing you why it works for right now. For example, if I put an ordered pair here at -4 and 5, so I have one of them at -4 and 5, and I put another one here at 1 and 2. And I want to find the distance between those 2 points. You guys in the past would just use this formula, substitute everything in, press a bunch of buttons, and hope that you get the answer correct. Now, when you did that, if you weren't careful, it was way too easy to accidentally get the wrong answer because you don't put parentheses around a negative. Ever screwing that up all the time? Now, it happens still the same here. But what I want you to think of is change in x. On a graph, what direction do the x values go? Do they go left and right or do they go up and down? They go left and right. So when I say the change in x, I'm looking at this horizontal change. Okay? There's my change in x. When I say the change in y, I'm talking about my vertical change. Okay? The vertical change. What did I just make? Triangle. More specifically, a right triangle. Very good. Now, when you think about a right triangle, there's a little known theorem that you guys all have used in the past, which is called the Pythagorean theorem, okay? So Pythagorean theorem says a squared plus b squared equals c squared. Now, in geometry, we don't talk about the Pythagorean theorem at all until second semester. I think it's kind of stupid because you should be using it whenever you can. Now, in Pythagorean theorem, one value is more important than the other two. The hypotenuse. Which one is the hypotenuse? C. The longest, right. The longest one, the one across from the right angle. This value of C is the hypotenuse, and the hypotenuse will always be the longest length inside of a triangle. Second semester, we explain why that occurs. Actually, it's the first semester. But anyway, this will always be the value of C. The other two are completely interchangeable. Because if you think about it, what's 3 plus 4? And what's 4 plus 3? The order in which you add things together isn't going to matter. So the order in which I add something and square it isn't going to matter either. So what I want to do is just think about, well, how far apart are my x values? Well, from -4 to 1 is how far? It's 5. Okay? From 5 to 2 is how far? Don't care about negatives. We're not doing negatives. Don't worry about negatives here. Just how far apart are they? 3. Distances will always be positive. When I walk backwards, I'm not walking a negative distance. I'm just going a negative direction. I still went 3 steps backwards. See what I'm saying? So when you start thinking about this in terms of just straight Pythagorean theorem, you don't have to worry about the negatives. You don't have to worry about grouping it correctly with your calculator, so you won't be screwing that part up. So you wind up with 3 squared plus 5 squared and take the square root of it. What's 3 squared? 9. What's 5 squared? I get the square root of 34. In my calculator, I just press the square root of 34. Sometimes, depending on the calculator, it might just say the square root of 34. Multi-view calculators will simplify the radicals for you. If this was able to simplify, it might say 2 root something. Like the square root of 8, 2 root 2. Square root of 12, 2 root 3, and so on. Whereas square root of 34, it doesn't give you an answer. So if you've got the multi-view calculator and it just says square root of 34, great, write that down. That's your answer. If not, it might give you a decimal, 5.83. In this class, I'm always going to round to 2 decimal places, the nearest 100. So if you don't have the multi-view calculator, your answer would have been 5.83. Either one of those is fine. I know you have it, you just wrote it down the other way. That's okay. Okay? Again, what I want us to look at is that I want to treat it in terms of a Pythagorean theorem problem, because you're trying to find the hypotenuse every single time. Find the difference between the x values. I mean, not difference, but how far apart they are, how far apart the y's are, square each of those, add them together, and take the square root. Okay? Let's try another one. Yeah. Let's find the distance of let's find the distance between those 2 points. I have no graph. I don't care about a graph. I don't need a graph. Okay? I know that if I know how far apart 4 and 7 is, it's 3. I square it. How far apart is -3 and -4? It's 1. Distance. Are distances ever negative? Nope. It's just they're just 1 apart. I square it. Take the square root of all that. What's 9 squared? Sorry. What's 3 squared? 9. Hey, very good. What's 1 squared? What's 9 plus 1? And according to your calculator, the square root of 10 equals the square root of 10. Or it'll give you a decimal equivalent of like 3.2-ish or something. Okay. Again, all I'm doing 3.16, sorry. Okay? All I'm doing here is just counting how far apart they are to get the change. What's the distance between the two? That's what that means. If I did it long form, I would have said 7 minus 4 quantity squared plus -4 minus a -3 quantity squared, got the square root. 7 minus 4 is 3, 3 squared. -4 plus this would be -1 quantity squared. And then I would have gotten 10, and I would take the square root. You're doing right. That's why I'm saying use your brain. Count. You'll be okay. All right? Use your brain and count. That's what you're supposed to do. Okay? One more. Sure. Find the distance between these two guys. Okay, same idea. Help you see the board better? Okay. There's always one. Go from -5 to 3. That's how far apart. So When I'm doing distances, I just want to know how far apart they are. How far apart is 0 and -6? 6. Again, you walk backwards or you walk in a negative distance. You're just walking backwards. Okay? From -5 to 3, how far apart are they? 8. 6 squared is? 8 squared is? Square root of 100 is? There's distance. Now, this, I've shown this one to the other guys as well. This one is what we call a Pythagorean triple. We talk about this later on. Pythagorean triples, very common one is what we call a 3, 4, 5 triangle. What's 3 squared? What's 4 squared? 9 and 16 is how much? 25. The square root of 25 is 5. So if I multiply all of these by the same number, like 2, what's 3 times 2? 8, 10. 6 squared plus 8 squared is 10 squared. These things come in really, really, really handy. Also, have any of you guys ever helped your parents build a wall, put in a patio, or anything like that? And you know how?
Every day.
Good. Now, when you did that, you had to, when you build walls and put them together, when you join the walls, you have to make sure the walls are what we call square to one another. If walls aren't square, you can't hang drywall, things fall off, and it's bad news. So what happens is, and this is a very common thing. What you do is, from the corner, you would measure out 3 feet. From the corner, you'd measure out 4 feet, which means if this is a right angle, this distance from here to here should be 5 feet. If it's not, you would adjust it to make sure it works. After you do that adjustment, you would measure out 6 feet, measure out 8 feet, and from here to here, it should be 10 feet. That's why we use Pythagorean triples. It is an extremely useful tool if you ever build anything to see if something is square. No, because if you go, oh yeah, I'm sorry, yes, 12. I was thinking of, yes. Hi, how are you? I'm great, thanks. Yeah, it would be 12, 16, 20, I believe. Well, oh no. Yeah, 12, 16, 20, yeah. Okay. So I had already posted problems out of the textbook for you guys, and I accidentally erased it on here. If you look at the calendar, I have a total of 9 problems. It'll be all right. As you go through them, you've got 3 of them where you're finding the midpoint. You've got 3 of them where you're finding the missing endpoint. You got 3 of them that are finding the missing endpoint, and then 3 of them that you're just finding the distance. There is a textbook up front here. If you want to take a picture of it. Otherwise, it's posted. You just have to pull up the problems out of the book. But I expect you to start working on it now. And with any luck whatsoever, you'll probably have, I don't know, at least half of it done before you get out of here. Okay? Please get started quietly.